Welcome to the next section of the course. So, here in this section, we will be focused on forming. The first section, we were more focused towards casting. Casting and forming fall under the category of constant volume processes. So, that means to say starting material and the ending material will be approximately the same. I use 1 liter of aluminum alloy, I make when I convert into volume and density and other things, I try to get a similar one. I start with 1 kg, I get approximately 1 kg, right. So, in metal forming also it is the same story. What is the difference? The difference is, there we converted the state from solid to semi-solid to liquid and then we started pouring into the mold. But here we are not going to change the state. We are going to use a solid as a solid and try to give a shape to it. Friends, in manufacturing there are only 3 parameters which are very important. One is pressure, the other one is temperature, the third one is time. When we did casting, we used only 2 of these parameters, temperature and time. We did not go through deep in die casting. In die casting, we also use pressure. Whereas, when you come to metal forming, it is more focused towards pressure and time or pressure and temperature. These are the 2 things, but the predominant parameter is going to be pressure. What is pressure? Pressure is nothing but force applied per unit area. If I have a solid, now I apply a huge load on top of it such that it deforms. Let us take a simple example in your kitchen. You make a small ball out of atta, you roll it and make it out of atta, and then what you do is you keep it on a flat plate and you have a roller to roll on top of it. Now, the ball shape item whatever was there which occupied a smaller area, now you try to spread it, you increase the surface area, but reduce its thickness. The starting volume whatever was there and the ending volume will be the same. Where is the difference? It is the surface area. So, here you can clearly see when I apply pressure, I try to deform a raw material. So, those processes are called as forming. It is a very important process. If you see, forming plays a very important role and several applications are there. For example, when you see doors which are there, which are made out of metal, they are made out of forming process. The door frames are made out of metal forming process. The car bonnet is made out of metal forming process. The rocket casing is made out of metal forming process. The sharpener which you use for pencil, you see a small blade made out of metal forming process. If you see a scissor made out of metal forming process, a spanner made out of metal forming process, a stand which is used for taking video, a tripod made out of metal forming process. So, almost everything is made out of metal forming processes. It is a very important process. So, let us try to understand fundamentals of metal forming process. In this process, or we have 2 weeks exclusively we will be discussing about metal forming. So, we will have the flow like this. First, we will try to have an introduction, then we will try to have classifications like we had in casting classifications, expandable mold, non-expandable molds, right. So, like that here also we try to classify. Classify how? We will try to classify based upon the raw material available to us. That is one way of doing it. Then the shape what it is to be done, for example, whether it has to be continuous or discrete. So, we will see the classifications. Then we will try to see the forming mechanism, that will be the third part of it. The temperature plays a very important role. You also know it. Suppose if you cannot bend it, we take a spoon, if we try to bend the spoon, or we take a rod, we try to bend it. If we see our force is not enough for it to bend, so naturally what we do is we go to the kitchen, start the burner, heat the rod, and then it gets slightly softened and bent. So, effect of temperature will be the next one we focus. Then we will try to see what are the different types of processes: cold working process, warm working process, and we will try to see hot working process. So, then we will try to see various bulk forming processes like rolling. Right from history, we will see rolling analysis, outcomes, rolling mills, operation and defects. Finally, we will try to recap with some references. If you look at the figure where the animation is going on, you see two rollers are there and a thick plate is pushed inside. When it is pushed inside, the roller rolls. When it rolls, it tries to drag the material inside, and when the load is applied, you see the width expands and the thickness reduces. So, basically the surface area is expanding, the volume is the same. Okay. So, that is what is shown in this animation. So, metal forming includes a large group of manufacturing in which plastic deformation is used to change the shape of the metal workpiece. When you try to look into the stress strain diagram, we had for aluminium alloys like this. So, you will have elastic limit, then you will have plastic. So, when we are doing metal forming, we cross this state elastic, we enter into plastic, and then we try to give a shape to it. If we go further down, it will try to break. So, we do not get into that area. So, here interestingly, when you get into it, there is a phenomena called as strain hardening. The strain hardening phenomena happens and you are able to improve the mechanical property, get a very hard output from the sheet, and then you try to give a shape to it. So, that is metal forming. So, metal forming, we work on plastic region. It is very clear, you have to apply so much of stress to get the strain. What is the strain? The strain can be elongating in one direction or in the cross direction, strain. So, in which the plastic deformation is used to change the shape of the metal piece. For example, you want a spoon to be made. So, spoon, the basic material will be flat plate, and then when there is a load applied, you try to get the shape of a spoon, right. So, that is basically a shape is given to the metal piece. In forming process, the metal deforms to take a shape determined by the geometry of the die. So, when I have a sheet and if I apply pressure, now wherever I apply pressure, the sheet tries to deform. So, there can be irregular shapes what is achieved. So, what I do is I try to deform in a geometry which is given to the die. So, this is called the die and this is called the punch, where in which you apply load, and this is the sheet which is getting deformed. So, plastically I deform to a given shape such that I get the output. The shape is given to a die. So, you can have geometry depending upon your requirement. In this process, the stress applied to plastically deform the metal are usually compressive, right. By and large, it is compressive. What is compressive? You have a workpiece, you try to hammer the workpiece to get the output. That is compressive force. When you have a workpiece, when I try to pull tensile, this is called as, this is compressive, this is tensile. So, by and large, the compressive stress is applied to the sheet and then it tries to deform. So, that is what we say compressive load is applied, right. Even in the previous example, you can see between the two rollers there is a compressive load which is applied, which when it tries to extract gets converted into tensile, because you are compressing it, you are allowing it to have a free end, so it expands. But friends, remember, what you have input, the same volume only we will get. There can be change in the dimensions. Most reliable properties for forming include low yield strength and high ductility. So, the strains will be very high. That is why we try to choose all the ductile material as the workpiece. For example, we try to take aluminum, copper, titanium, magnesium, steel, wherein which you can easily deform. Cast iron cannot be deformed. So, there is not much of ductility, cast iron cannot be done and it has a high yield strength. Strain rates and friction are additional factors affecting the metal forming process. What are strain rates? I try to slowly stretch. The straining is slow. Strain divided by time is the strain rate. If I slowly move a metal, it is slow strain rates. When I quickly, instantly move it, it is called as high strain rates. For example, you take rubber band, elastic rubber band, you slowly drag it, you can keep dragging it to a far extent. But you drag it at a very high strain rates, it fails at an early stage. So, that is strain rate. And the other thing you should understand, friends, we keep the sheet metal between metal. So, this is a metal die and this is a metal punch, right. So, the workpiece will have a contact, metal to metal contact. When there is metal to metal contact, there is always a friction. See, when you try to take even a elastic eraser, or when you try to take even atta, when you try to press it, right, when you try to press it, it is contact between the finger and the workpiece volume. When I try to drag it, there will be always a friction component. If there is no friction, the deformation becomes easy, but it is not controllable. So, why is that friction coming? I will try to explain in the next slide. Why is that friction? Because any metal, this is the theoretical metal you have, but if you look at it in a microscopical manner, you will have all sorts of undulation on the surface. This is theoretical, this is real. Okay. Then now I have another surface, assuming that this is the die surface, this is the workpiece. You have a die surface which is there, and all these things, these undulations, I am talking about 1 micron. Your hair is 100 micron, 1/100th of it, right. Typically, your hair size is 70 to 80, assuming it 100, 1/100th of it is this undulation on the surface. When this is trying to move, and here I have something else, like this is the other workpiece, which is die workpiece. This is workpiece. You can see at several places there are metal locking. This metal locking tries to lock the material from flow. Now, you are giving pressure. So, it has to break the locking and then it has to move. So, this will create friction, and the friction, if it is very high, it can also create heat. So, what does it mean, or what does the inference we get out of it? So, when metal forming operations are done, you will always look for lubricants. What is the function of the lubricant? Lubricants will flow inside this undulation. It will form a thin lock. So, when two surfaces are there, one will try to slide over the other. So, at room temperature metal forming, we always try to have a lubricant. It can be oil, it can be soap water, it can be molybdenum sulphide. whatever it is depending upon your requirements. So, what is the advantage of metal forming process? It is highly efficient. Why? The starting material and the ending material is the same, and the starting material it gets into a plastic zone, strain hardening, and then you get the output. So, its hardness value to some extent improves, and the mechanical property also improves. It improves the mechanical property. Metal forming are always used for higher production rates. If I wanted to do any part or a product in numbers of few thousands, then we always look for metal forming processes. So, it has a very high production rate. Very complex shapes can be made. When you do in casting, what happens? We have already seen, if there are very small features, all these features has to be given to the mold, and when you pour material, the liquid might not fill up the all small features. So, you will get a round off shape, but in metal forming, since you apply pressure with the known volume, it always tries to take a complex shape under design. It is a very cost effective process. Why? Because it is used for higher production rates. Almost all the sheet metal work which is done, let it be a chair, everything is made out of metal forming, because the production rate is phenomenally high. It has a very good surface finish and dimensional accuracy. It need not undergo a finishing stage. There can be excess material available which flows out, we will trim it off, that is called as flash, and that flash can be removed, but by and large it gives you a good surface finish and a dimensional accuracy. It is a versatile process, and whatever it produces, it is consistent and it is reproducible. Like in casting, what happens? Whenever there is a air bubble, right, there is an air bubble, it tries to produce a defect. Whenever there is a erosion of the mold material, it gets, but here such things will not happen. So, it has a consistency and it is also reproducible. It is customizable. That means to say, you can try to play with the die, punch, whatever it is, you can try to customize, and almost all the lightweight components wherein which the sheet thickness is 1 millimeter or less than 1 millimeter, we always go for metal forming processes. If you look at an aeroplane where we all sit and travel, it has a structure. The structure is also made by metal forming. The other thing, the cover of the plane is also made by metal forming. The sheet metal, whatever is there, is made by metal forming. So, metal forming is a versatile process. Saying this, it also has some amount of disadvantage, because it is used for higher production, repeatable, reliable process. The initial costing is very high. That means to say, the die and punch cost is high. Cost is high. Second thing is, if I have to apply a huge pressure, what is pressure? Pressure is nothing, as I told you, it is force per unit area. I need a machine which is used for doing it. So, typically the machines what we talk about in normal domestic applications, we talk about 10-ton machine, it can go up to 100 tons. So, this is the load it gets created in the machine. So, the machine itself will have hydraulic, it will have electronics. So, all these things are expensive. If there is a good machine, very good controllable machine, it can go from few 1 crore, it can go to few 10 crores, right. It has residual stress, because what is residual stress? Residual stress is when you try to change the shape of your rod, right. When you try to change the surface, this is the, for example, this is a rod, you try to deform it into a U shape. Okay. So, here there are tensile stresses on the surface, and at the bottom you will have compressive stress. So, this will be compressive, in the top you will have tensile. So, from here to here, if you try to draw, this is tensile and this is compressive. You see here it goes like this. This is I am just drawing a cross section. This is tensile stress on the surface. This is compressive stress on the surface. This is positive side and this is negative side. So, within this thickness there is a transition happening. This will try to introduce residual stresses in the material. Since you have working on 10 ton to 100 ton, the energy consumption is very high. And anisotropic is, if you have a sheet, if you are rolling this sheet in this direction, so the tensile strength along this direction will be higher than cutting a piece in this direction. This is tensile running along the direction and I draw perpendicular to it. Again I do here tensile. I will see here difference. So, it has different property in varying direction, and suppose if I cut at 45 degrees angle, then I will get a different response in the tensile test behavior. Of course, all these things will have a certain error of 10 to 15%, there will be difference, but it can be accommodated. Tool wear and maintenance is also part and parcel of the limitation. So, these are few limitations, but saying these limitations, you see lot of advantages are there in metal forming. So, if you look at it, these are some of the applications. So, you keep a metal part there which is called as a ingot or a chunk of material. Now, I apply compressive force on both the directions. So, wherever there is the compressive load is there, now the material will try to bulge and expand. When it bulges and expand, wherever there is a free space, it expands in that direction, and after some time it keeps expanding, but I try to confine it by this dead end. So, it tries to get the shape whatever I want. Right? This is one application we can try to get, like a stamping or you can say a forced impact process. So, the load can be continuously done or the load can be impact. It can be continuous means you are trying to reduce it, impact means tuck, 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 tuck. So, at regular intervals of time you apply a heavy load. So, it tries to take the shape. The spanners which you use in automobile industry are made by forging process. It is impact forging process. If it is a larger component, we make drop forging process, right. The wheel axle are made out of metal forming process. The next one is extrusion process, wherein which we have material there and then we try, this is a die, the die gets the shape of the output. So, we try to pull material across the die and get the shape of it. So, the application is the frames, the tubes, whatever you have, they are made out of this extrusion process. So, you can pull here and also parallelly you can push it here. So, these are all extrusion process. This is a rolling process, wherein which you have two rollers or rolls. These rolls rotate and they rotate in opposite direction with different speed. So, that what happens is the metal is dragged inside and it is thrown out. Okay. You try to get a flat plate sheet out of it. Here the cross section area will be uniform. Here also it will be uniform. So, this is used for continuous process until the raw material is here. This is also called as a continuous process. Moment it is exhausted, then you put the next roll, but the output will be the same. In die, it is discrete part manufacturing. Okay. A tube, this is a tube. The tube can be done by extrusion process. So, here we do a tube bending process. Next, we try to make a curvature on the given object. So, this is also possible by a roller. So, this big structures are also made out of metal forming operations. Now, let us see the classification of metal forming process. The metal forming process is classified based upon the raw material available. If the raw material is in an ingot form, where the volume is high and surface area is low, they fall under the category called bulk. If the volume is less, surface area is large, then it gets into sheet metal metal forming operations. So, sheet metal forming operations are used because are commercially used in a big way, right. Under the bulk, what we do is we try to classify the process. So, first classification is a rolling process. We will see individual rolling process. Then it is forging, which I told you an example of impact forging. Extrusion process, wherein which I put material and pull. The wire drawing process. So, all these processes are bulk deformation process. The wire which we use in the electricity, that is also made by metal forming process. So, these are the 4 major process which form under bulk deformation process. Sheet deformation processes can be bending, deep cup drawing. For example, the glass tumbler, the aluminium glass or stainless steel glass tumbler is made out of deep drawing. Wherever the aspect ratio, wherever the depth to diameter ratio, depth to diameter ratio is high, we use cup drawing process. Depth can be here it can go from 3, the ratio can go 3 to 100 also it can go depending upon the requirements, right. Then shearing process, in many of the sheet metal operations you can see sometimes there will be holes in it, those processes are called as shearing process. Then you can have other miscellaneous processes. There can be a combination of bulk deformation and sheet deformation together, those processes are variant or sometimes it is called as hybrid processes. Okay. But these are the very basics. In this course, it is good enough if you go through some of the basics to understand and appreciate the classifications of metal forming processes. Now, let us get into little bit of mechanism of forming. In the metal forming, the plastic region, the stress strain is of primary interest because the material is plastically deformed. This is what I said, plastically deformed, and it can go to any extent, right. So, this is fracture. We do not want to get into the fracture zone. We will always try to get from here to here, we will try to stop, right, in the plastic region. So, permanently deformed in these processes. So, in the plastic region, the material behavior is expressed by a flow curve. This is called as the flow curve. The stress is equal to or directly proportional to strain to the power n, where the constant, when we remove the proportionality removed, there is a constant. So, that is called as strength coefficient of a given metal, where n is exponential hardness, right. This depends on the material property. N is a material property, K is also a strength coefficient. The stress and strain in a flow curve are true stress and true strain. The flow curve defines the metal's plastic behavior in cold working only. When the temperature is increased, this they have a change in it. Okay. So, this is already dealt, so I do not have to go in depth. As the metal is deformed, its strength increases due to strain hardening. That is why you see here there is a phenomena from here to here, there is a strain hardening. There are 2 phenomena hardening. One, the as and when you do tensile test, when you keep on expanding, so you see the material also slowly gets necked. It gets slowly necked and then you get something like this, right. So, there is a reduction in the area of the material, plus there is an increase in load. So, both these things try to come to the strain hardening behavior. So, the flow stress is defined as the instantaneous value of stress required to continue deforming the material to keep the metal flowing is called as flow stress. it is the yield strength of the metal as a function of strain, which is expressed as this, where the flow stress is YF, which is equal to K times strain to the power N, which is the exponential hardness coefficient. Except some cases, generally forming force is analyzed on the basis of average flow stress and strain. So, what is average flow stress? Right? Plastic limit, maximum, ultimate strength. We always try to take the mean. So, that is what we say average flow stress. So, the average flow stress or the mean flow stress is expressed in this way. So, it is the average value of the stress over the strain, stress strain curve from the beginning of strain to the final value that occurs during deformation. So, mean can be expressed in this way. So, Y dash is called as the average flow stress and maximum strain values are strain during the deformation process, where N is exponential strain hardening. N is the strain hardening exponent. So, role of temperature. If I have a machine where in which there is a restriction, I can't apply heavy load. So, next thing what we do is we try to get into heating the sheet so that we soften the sheet. So, the sheet metal operations can happen at room temperature. It can happen slightly above room temperature and hot working on the above side. So, it can be less than 30% of the melting point, it is called as cold working. Between 30 to 50% of the melting point, if you heat it and work, it is called as warm working. If it is hot within 50% to 75% of the melting point, you heat the material and then you deform, it is called as hot working. So, here what happened, more and more you try to go down, the energy what you apply to the process increases. Okay. So, role of temperature, energy increases, the force whatever you apply on deformation decreases. So, role of temperature is very, very important. In metal forming, high temperature reduces the strain hardening and the strength both. Also, it increases ductility, which in turn reduces friction and power consumption. So, this point is very important. It does so many things, reduces strain hardening, strength, ductility it increases, it reduces friction as well as power requirement. Friction is reduced, power requirement is reduced. How is friction reduced? The metal locking whatever is there will not happen so strong when we try to increase, because the material is soft, it will just drag and keep moving. The effect of temperature in forming process are distinguished by following the three types of working or forming. Friends, this is a thumb rule. There can be up and down variation, from book to book variation can be there, but this we will try to assume that there are three and these are the range with which it is working. So, what happens is there is a phenomena called as recrystallization happens when you are doing hot working. Recrystallization of metal in hot working involves atomic diffusion, which is a time dependent process. The recrystallization temperature for a given metal is about 1/2 of its melting point on the absolute scale. So, we try to play around with the recrystallization temperature. Isothermal forming. So, thermal means you are using temperature, iso means uniform. It refers to forming operations that are carried out in such a way as to eliminate surface cooling and the resulting thermal gradient in the workpiece. So, you can see here original coarse grain structure will be here. Now, you are doing an impact. So, now you can see here the plastic deformation, there is an elongation of grain. So, recrystallization, equiaxial grains are getting formed. There is grain of new, the growth of new grains happens as and when you move in this direction. So, by temperature and force you are trying to play with the grain. So, if you go back to the casting, you will see equiaxial grains formed just close to the mold metal interface. You can see that, right? Why is this grains? Because there is a gradient. That is a similar thing happening here. So, plastic deformation, elongated grains are there. Then you have equiaxed grains on the top because thermal gradient is there. Then whatever is there, when you, because of it, when you try to push it further, there is a growth. So, it refers to forming operation that are carried out in such a way as to eliminate surface cooling and the resulting temperature gradient in the work part. It is accomplished by preheating the tools that come in contact with the part to the same temperature as the work metal. Okay. Preheating the tool or the workpiece. Metals and alloy having good hot hardness property are formed by this method. So, what are hot hardness? At high temperature, the hardness is still maintained. So, there we use this isothermal forming, iso uniform temperature thermal. Cold working process. Cold working process is a metal forming performed at room temperature or slightly higher than the room temperature. It gives you accurate results and it gives you a close tolerance. It has very good surface finish, high strength and hardness of the part due to the strain hardening behavior. This is very good, right. In fact, heavy deformation, if you have a machine, for example, rail wheels are made out of forging. So, high strength and hardness of the part due to strain hardening is achieved in cold working process. The directional property can be obtained in resulting product due to better grain growth during deformation. No heating of the workpiece is required, resulting in easy product handling. It is low cost and the production rate is also higher. So, what are the disadvantages? The force and power required are very high. The surface sometimes might start to have scales. Scales are oxidation layers on that surface. You might have to do some removing operation. The surfaces of the starting workpiece must be free from scales and dirt. Otherwise, what is happening? The oxide, whatever is there, when it is trying to mix, the oxides try to dig into the workpiece and you have some undulation on the surface. Ductility and strain hardening of the work metal limit and the amount of forming can be done for a part. Annealing of the surface are required before forming. So, you do that and then you get it done. So, now this talks about the advantages and disadvantages of cold working process. When we talk about warm working process, the term warm working is applied to its second temperature range of 0.3 to 0.5 Tm. The dividing line between cold working and warm working is often expressed in terms of melting point of the metal. It is sometimes performed at temperatures somewhat above room temperature, but below recrystallization temperature. The low strength and strain hardening at the intermediate temperature as well as higher ductility provide warm working with the following advantage of lower force, lower power, more intricate workpiece geometries can be done, need for annealing may be reduced or eliminated, which is a prominent phenomena for room temperature working process. Hot working, where the temperature goes above 0.5 Tm. So, it is annealing temperature. The shape of the work part can be significantly altered by using hot. If you are trying to deform a large volume in a short time, you heat it. Low force and power are required. Brittle metals that usually fracture at cold working can be done in hot working. For example, cast iron is a brittle material. You want to still deform, try to take it to a higher temperature and then try to deform. Generally, cast iron are not done by hot working process, right. You have to think of some other material. Hot worked products have isotropic strength property. No strengthening of the part occurs from work hardening. So, low dimensional, because you do it in cold, you do it in hot. So, dimensional accuracies will be low, the energy applied is high. When you are heating, the oxidation phenomena happens so fast, Moment oxidation happens, there is a poor finish and the tool life is shorter, because here you heat and cool, heat and cool, heat and cool. So, it undergoes thermal cycle, and because of the thermal cycle there is lot of wear and tear, it has to be replaced. So, hot working process, the die cost is high and maintenance of die is also expensive, So, what are the factors which affect the forming process? In metal forming, it arises because friction in metal forming arises because of the closed contact between the tool and the workpiece surface and the high pressures that drive the surface together in these operations. So, metal to metal contact with pressure leads to friction. In most metal forming process, friction is undesirable for the following reason. Metal flow in the work is retarded, causing residual stresses and sometimes defect in the part. When there is a friction there, so what happens naturally, the flowing of metals will not happen. If the flowing of metal does not happen, there will be always cracks in the workpiece. You will have cracks because there is improper flow. Metal flow in the workpiece is retarded, causing residual stresses and sometimes defects in the products. The forces and power to operate are increased. Tool wear can lead to loss of dimensional accuracy, resulting in defective parts and required replacement of the tool. If the coefficient of friction becomes large enough, a condition known as sticking occurs. So, like you have rubber band sticking, chewing gum sticking, then you have eraser sticking, right. Like that, you also can have a phenomena called sticking phenomena between metal to metal. Okay. This is quite common when you try to do cold working process. It is called a stick slip phenomena or sticking phenomena. Sticking in the metal forming is also called as sticking friction, is the tendency for two surfaces in relative motion to adhere to each other rather than sliding. It means sticking occurs in metal forming operation is a prominent problem in rolling. So, friction is one factor which affects the forming process. So, we always try to use lubricants between the tool and the workpiece to reduce the harmful effect of friction. Lubrication reduce sticking phenomena, force, power, tool wear, better surface finish, and lubricants can include for cold working and hot working. In cold working, we use mineral oil, fats, fatty oil, water based emulsion, soaps and other coatings. When we work on hot working, we try to use mineral oil which has a higher boiling point, and then we use graphite. Graphite are nothing but a form of charcoal, graphite, and then we also use molten glass as a hot lubricant while deforming. So, friction is one of the major factor which affects the metal forming process. Now, let us get into bulk forming process. This process are generally characterized by significant deformation and massive shape change, and the surface area to volume of the workpiece is relatively small. Right? Surface to volume, surface is less, I said. So, surface area will be less, volume, you have to see the ratio. People also try to call it volume to surface area. So, you see, understand what is it. The starting workpiece for these processes include cylindrical billet and rectangular bar. Cylindrical billet are because when you try to cast it and pour it, you try to form billets. Billets are cuboidal, which goes for long, lengthy one, heavy objects. From here, we try to apply force and reform to get the required output. So, billets and rectangular bars are the starting material. So, the bulk forming process is rolling. So, I can put it between the rolls and then I can try to deform to get a flat plate. I can forge to get a discrete part. I can use it for extrusion. I said we apply force from the back. it is a die and then the workpiece flows out. So, it has a uniform cross section extrusion process. Wire drawing is also done. So, the difference between the extrusion process and the wire drawing process is, here the input is continuously coming. Here we have a billet, we push the billet and then again you have to load another billet to do the deformation. Wire drawing, and when the diameter is large, we call it as bar drawing, right. Thank you so much.